Greetings from Stanford University. I'm Bill Barnett, professor at the Stanford Doerr School of Sustainability and the Stanford Graduate School of Business.
And I'm Charlotte Kramer, a current undergraduate at Stanford studying computer science with a minor in environmental systems engineering.
And we have with us here today Hamdi Tchelepi, who is chair of the Department of Energy Science and Engineering at the Stanford Doerr School of Sustainability. And Hamdi, we just had a conference that you chaired on scaling geologic storage of CO2 to impact global emissions. And Charlotte, you were there. Tell us, what are your reactions to the conference?
I thought it was an amazing conference personally. I loved how different people's perspectives were on the topic. I think there were sort of three different fields of thought, talking about scaling, talking about how useful it is, and then talking about the idea of environmental justice and the sort of NIMBY stuff that we see all over environmental issues. So this idea that it's great, but not in my backyard.
What a provocative combination of topics. Hamdi, did you come up with that combination?
Yes, in a collective effort with my co-chairs, Sarah Salzer and Tony Kovcek. What we wanted to do was to bring in people who can give perspective and advice on things that are not directly related to the technology, but almost everything else. The regulatory component, the policy component, the social acceptability component. And so we wanted to make sure that it's not a geeky conference for engineers, but rather a high-level conference in the sense that we wanted to be holistic, tackling the entire system, tackling it from a scale perspective and from what can be done perspective, as opposed to pontificating theoretically about what should or could be done.
Yeah, to that extent, I think at the start of this conference, we really talked about looking at previous energy transitions. So looking at the way that we moved from various fossil fuels to more electric forms of transportation. And then we saw that looking at past transitions, it would take approximately 60 plus years to sort of give up all of our fossil fuels, which is entirely unrealistic. And it's just not the right scalability rate that we are looking for. But then in comparison, when we look to the invention of cars, taking over the position of horses and carriages, we see that that transition happened almost overnight. So how do you see the scaling of carbon capture and storage happening in a more long-term or almost overnight effect?
Well, I don't think we have 60 years, as you said. So it's an urgent call for putting away the CO2 in quantities that would matter. Understanding that CO2 sequestration in the subsurface, which is the topic of the conference, is only one of a portfolio of mitigation strategies. But in order to really make a difference and meet the IPCC targets, we need to start putting away the stuff at the gigaton scale per year, which is more than an order of magnitude more than what we see today. And in order for that to happen, everyone has to be pulling in the same direction. And in order for that to happen, the regulatory components need to be in place to make it a viable business model for people to put the CO2 away. And all of these things are actually in flux. Which adds to the concern that if you want to take this seriously, we need to act with the urgency that the planet requires, which really means that the policy people, the politicians, society at large needs to start making big decisions and get this thing going.
That's so interesting, and I want to just step back briefly and remind our listeners that the reason we're talking about putting away CO2 at scale is that when carbon dioxide is released into the atmosphere, it's essentially there permanently, unless we do something about that. And there are carbon cycles that people know about just from their grade school days, but essentially that carbon is there, and continuing to use up that limited carbon budget as we continue to depend on carbon-based energy systems. And it's made it so that while there may be lots of debates going on in the modern world around climate, there's very little debate about the idea that we have to put this carbon away.
Yeah, I think referencing here Steve Chu, the former Secretary of Energy, he was talking about how history tells us that the speed of innovations was often driven by war, imminent threat of nuclear holocaust, market forces, i.e. financial gain, as you were saying, so this business model idea, or just in-your-face pollution, which, irritates the entire world. So, for example, in the case of horses versus cars, horses would leave manure all over the streets and there'd be straw everywhere. So it was really this in-your-face pollution that fueled this move towards cars. So maybe by making the issue of increasing CO2 emissions in the atmosphere an in-your-face issue, we could hope to move a bit quicker on this.
Sure. So actually, in-your-face pollution is a primary driver for better environmental regulations in places like China and India. And as you clean up the air from pollutants, you can think of CO2 as one of those pollutants and put that within the umbrella of environmental stewardship. But I think even if some of these largest countries view it as an in-your-face pollution requiring immediate action, that's not going to be enough. We need the entire planet to really deal with it as an urgent issue. And in order for the public to see that, they're going to have to trust that the politicians and the leaders of their communities actually preach consistently in that direction and show the urgency of action.
Well, that's another really interesting point, that we have no declared war on climate change at the moment, even though I think amongst the scientific community, there's a massive agreement that there really should be a war on climate change at this point. And it just reminds me of the fact that we're not even seeing the full implication or ramifications of our actions right now. Again, Steve Chu noted that until the oceans fully warm up in approximately 50 years, we're never going to be able to see the full extent of the damage that we have already done, let alone the damage that we're still doing today. So I really left the conference with this question of why is it sort of written in stone that things have to get really, really bad before the world will come together to fix an issue?
That's interesting. It's a behavioral proposition being put forward here. And, when you think about the issues we're dealing with, they are technical, they are behavioral, and they are ethical, all three. And there is a large behavioral literature that is consistent with Steve Chu's point on in-your-face being motivating. But it's also understood that behavioral change can happen even when the causes are more indirect and not so proximate. Did that come up at all in the conference, Hamdi?
It did, and this is why most of the people in the conference were focused on exactly those topics: acceptability, social behavior, measuring social feelings, and figuring out ways of how you can possibly move the public in constructive ways, because the technology, as us engineers see it, is ready to be exercised. What is getting in the way is this acceptance by wide enough swath of the society including the public, the regulators, the politicians, to make it happen?
Yeah, I think at the end of the conference, we heard from the Environmental Justice Department of California, and they created this amazing video for us of, correct me if I'm wrong, a carbon capture and storage facility, and immediately saw issues from the community stating that residents' children started having asthma and that they blamed micropollutants in the factory doing this carbon capture and storage. So my question really is, how do we value these people's perspectives and their livelihoods being surrounded by this new technology, as well as our sort of aggregate?
Yeah, no, so that was actually an example, in my opinion, and I think in the opinion of the vast majority of the attendees, that was an example of how not to do such a project. The community had suffered enormously from decades of big industrial players coming in, promising X, Y, and Z, and taking the money away and leaving the community with pollution that affected their air quality, their water quality. So what I learned from that exercise is that's the last thing you would want to do. You don't want to go to a community that's already under stress, that is distrustful of business and government, and coin a project that is really not well thought out, and use that as the flagship of how to do things. So to me, it was a lesson of exactly what to avoid.
Yep.
There should be detailed assessment, co-design of these plans with the community. There should be conversations with the leadership and the average person in that community to let them know the benefits, the risks as you best know of them. It's also incumbent on scientists to be able to communicate those ideas to the public. And there are lessons learned from that case study. And we're already having conversations with several colleagues about constructing bases or frameworks for building case studies for when and how to go put a sequestration plant in place, avoiding all of the pitfalls of adding to the victimization of a community that's already been under stress for decades. So it was very informational.
So, Hamdi, that's incredible that that would come up in a conference that is, clearly on a very technical topic. It strikes me that this environmental justice concern around essentially who pays, who suffers the costs, is even more pronounced, I think, when we look at this globally. Right. When we look at the global north, you'll often hear people say we pay with money, whereas the global south pays with their lives. And hearing that this has gone on right here in California in the San Joaquin Valley, we know it's going on even more dramatically in other parts of the world. I could imagine a case study such as what you're talking about serving us well as a model for how to do things in other parts of the world as well.
Yeah, I mean, you touched on the essence of the problem, is that we want to put CO2 away globally, really, and the details of every project are going to be dominated by the local environment in which you operate. So putting the CO2 away in Japan or China or India or the San Joaquin Valley in California are probably all very, very different. The technical objective is the same. Putting together a framework to allow you to put the CO2 away all over the planet requires system-wide thinking, locally driven thinking, working with communities where they live, and understanding the context in which the benefits and the rewards are calculated, and they are different in different parts of the world. And the implications on what you do are could very well be quite different.
One thing which we brought up at the conference in reference to this was the idea of a social license to operate. So we have all of these environmental and technical licenses. We know why on a global scale we are doing this, but I think the idea of bringing carbon capture and storage more local and making it more of a social issue as well was really interesting. So this idea of, again, like you said, co-designing and really educating people about the risks and the benefits. So yeah, the idea of the social license.
Yeah, it's so critical, and it's already critical in the Western world. It's already very, very difficult to do something without the full support of the community through their representatives, through their proper representatives. That model is actually not the most common model for how you put things in place in the rest of the world. So you have to be extremely sensitive, as you said, to the details of the local concerns, how the local community values, manages its resources, and how do you convey the benefits and the rewards. What adds to all of these things is when you're putting CO2 away, you're really advocating for putting it away for the health of the planet. So every small community should be thinking of what they can be doing in support of the entire global system. That's a very hard ask in a lot of places on the planet. So we have to think of ways of incentivizing that, of making it possible, of allowing people to see that their local resources are being used to put the CO2 away in service of the larger humanity. That literally, I think, adds significant challenges beyond the technical details of engineering a particular CO2 project.
And you mentioned here this idea of representatives.
Yes.
So during the conference, one of the sessions that we had was on the question of what role the oil and gas companies should play in CCS projects. So I was wondering how you perceive their role in CCS as beneficial or detrimental.
So I see it as very beneficial, but I also, if you recall in the session, I raised the provocative question of should they be involved at all? And are there ways to do this without them? The thing that surprised me is I got pushback from almost everybody. So it seems there is agreement that the infrastructure in place, the engineering science that has evolved over the last many decades, if it's really put to use with this entire focus on putting the CO2 away and not worrying about extracting more oil, then they can not only be a major player, I would say there is no other player that can come in and deliver an infrastructure capable of putting 100 million equivalent barrels of CO2 in the subsurface. So in one of the sessions, we started by saying, what would it take to put 100 million barrels of CO2 away in the subsurface? And the reason we ask the question is, in order for you to put away CO2 enough to make a difference, it has to be at that scale, which is literally the scale of the entire oil and gas industry globally. So can we take the infrastructure of the oil and gas technologies that are able to move around 100 million barrels of actual oil and gas, can we use something like this and build an industry that can put the CO2 away at that scale? And if you ask who can do it, it really doesn't leave many other participants. So, so we need them.
You know, Hamdi, the skeptics out there listening will probably remain skeptical because of the tremendous financial interests that big oil and gas have. And of course, some leaders in that industry have even come out and stated publicly that such technologies would allow them to continue their operations longer into the future. But as I reflect on the opening comments Hamdi and Charlotte, that you guys opened this with, talking about a war on climate change. It reminds me of my late father when he talked about World War II and the changes in the world that he saw, that very unlikely allies came together. It was a time where organizations came together for a common purpose. Now, in that case, it was warfare. If we came out with that same kind of motivation for a common purpose to fight climate change, it doesn't mean that these organizations are going to become benevolent societies. It just means that the job they need to get done would change in its nature.
Absolutely. I think the real challenge is essentially twofold. One is, to use your words and Charlotte's, is to actually declare a global war for the benefit of the climate. And the second one is to make sure that everybody is on board, contributing to that objective. And there is actually a great deal of evidence that when human beings come together and they bring forces together towards a common cause, especially when you have technologies that can be applied at scale, that is doable. What gets in the way is the human nature of finding competing interests getting in the way of the global target. But I am convinced that we do need the equivalent of a declaration of war where the global society points in one direction, fighting the climate. And the contributions to fighting the climate will be very, very different from different organizations and entities. I, for one, and this is my personal opinion, I think there's a lot of support for that. I think the people who have put a lot of the CO2 in the atmosphere over the last 120 years should be order one contributors to putting the stuff away at scale.
Well put. Well put. Yeah, it reminds me of there's an old expression, lead, follow, or get out of the way. And if we're going to get this done, Charlotte, as the representative of tomorrow here, the member of the new generation that is the heart and energy and drive behind the sustainability revolution, we're going to give you the last word.
That's tough. I'd say I'm very conflicted as someone who has to live with this for the foreseeable future. I'll be on this planet for quite a while, so these decisions impact me and my generation greatly. I think I feel a lot of sympathy for the people who are affected by CCS and by all of the bad choices that we've made in the past. So I understand this social distrust, and at the same time, I am begging for it to start. I want us to start putting CO2 away because I know that is ultimately how I will have a nice planet to live on. So I think it's a difficult question. This conference was one step towards, a major revolution in CCS, but I'd say, we have to find a balance between pushing CCS projects and pushing regulatory frameworks. So making sure that everyone is in the loop and everyone understands why we are making these choices, why we are doing these things.
Well put, Charlotte. Hamdi, thank you so much. Charlotte, thank you. And to you listeners, until next time. The Stanford Initiative on Business and Environmental Sustainability podcast series is sponsored by the Stanford Graduate School of Business and the Stanford Doerr School of Sustainability. Music by Charged Particles. That's Caleb Hutzler, Mike Rock, and John Krosnick.